Welcome back. This is Mrs. Castaneda. This is part 2 in assembling the Raspberry Pi self-driving robot car. These are the materials needed in building the Raspberry Pi 3 platform: the chassis top board, the Raspberry Pi support board, 4 spacers, the Raspberry Pi 3, 3 plastic spacers, 3 small bolts, 4 medium bolts, 4 short Phillips screws, and 3 small slotted screws. Let's review safety measures and some components of the Raspberry Pi 3. Safety. Anything metal or electrical that touches the Raspberry Pi can damage it. Always hold the sides of the Raspberry Pi 3. These are the USB ports. There are 4. This is the micro USB connector, the HDMI connector, the mini SD card slot, the CSI camera connector, and the GPIO, the general purpose input-output header. Let's attach the Raspberry Pi 3 to the Raspberry Pi support board. Remember, handle the Raspberry Pi 3 carefully. Try to only touch the sides. Step 1. Align the Raspberry Pi 3 with the support board. We will only be using 3 screws to bolt it down. Step 2. Place the plastic spacers underneath the 3 holes allotted on the support board. Step 3. Screw the Raspberry Pi 3 onto the platform and bolt it down. Step 4. With the screwdriver, tighten the screw while holding the bolt. Let's mount the Raspberry Pi support board to the chassis top board. Step 1. Find the 4 holes that align the chassis top board to the support board. Step 2. Place a screw underneath the chassis top board and then screw on the spacer. Continue with the remaining. Step 3. Tighten the screws with the screwdriver. Step 4. Align the Raspberry Pi platform onto the spacers and bolt them down tightly. Let's pull the wires through the chassis framework. There are 8 wires attached from the dual H bridge. 1 wire is the power, red. The second wire is the ground, black. The remaining 6 wires are for motor controlling. 3 wires control the left motor and 3 wires control the right motor. Step 1. Pull the wires through the chassis. Step 2. Place the chassis board onto the bottom chassis. Step 3. Screw and tighten the top board. The breadboard is used to connect a circuit. Each row on the breadboard is connected by 5 holes. The breadboard temporarily connects wires together. The left and right side of the breadboard is divided by the ravine, which has no charge. In this picture, the adhesive backing has been removed from the breadboard. You can see lots of horizontal rows of metal strips on the bottom of the breadboard. If you connect a component to anything in that row, it will all be electrically connected to anything else placed in that row. Let's attach the breadboard. Step 1. Peel off the backing of the breadboard. Be careful, it is sticky. Step 2. Place the breadboard on the chassis as shown in the picture. Now we will connect the wires from the dual H bridge to the breadboard. Step 1. Connect the 3 wires on the left, which is the left motor, to the left side of the breadboard. The wire from the EA port goes into the first hole, the wire from the I2 port goes into the second hole, and the wire from the I3 port goes into the third hole. Step 2. Connect the 3 wires on the right motor, to the right side of the breadboard. The wire from the EB port goes into the first hole, the wire from the I4 port goes into the second hole, and the wire from the I3 port goes into the third hole. Step 3. Connect the power, that's the red wire, on the left side of the breadboard. Step 4. We will connect the ground wire, the black wire, to the right side of the breadboard. The Raspberry Pi 3 has 40 GPIO pins, general purpose input-output. Some will go unused. In order to use these pins, you must tell the system whether they are inputs or outputs. We are going to use Python to do this. This is a colorful diagram of the GPIO pins. This diagram shows numeration to simplify how to connect. Use this diagram when we are connecting the wires. These are the materials needed to connect the wires from the breadboard to the GPIO. 2 sets of 3 male to female jumper wires. 1 male to female jumper wire. Let's complete the circuit by connecting the motors that are already connected to the breadboard to the GPIO. Step 1. Connect the ground wire. Using a male to female jumper wire, connect it to the right side of the breadboard where the ground is connected. Now connect it to the GPIO port 9. Step 2. On the left side of the breadboard, place the second set of 3 wires parallel to those coming from the dual H bridge. Attach those wires to the GPIO. Wire 1 from port EA connects to GPIO port 3. Wire 2 from port I2 connects to GPIO port 5. And wire 3 from port I1 connects to GPIO port 7. Step 3. On the right side of the breadboard, place the second set of 3 wires parallel to those coming from the dual H bridge. Wire 1 from port EB goes to GPIO port 13. Wire 2 from port I4 connects to GPIO port 11, and wire 3 from port I3 connects to GPIO port 12. These are the materials needed to connect the LED light and the camera. Need a camera module, the camera mount, the small camera screws and bolts, the LED light, resistor, a large slotted screw and a large bolt, 2 male to female jumper wires. Now we will connect the LED light in a series circuit. Step 1. Place the LED light on the breadboard vertically. Notice that the shorter pin, negative, is on the left side. Step 2. Bend the resistor and place on the breadboard vertically. One end will be placed in line next to the shorter end of the pin, and the other end of the resistor has to be placed at least 2 spaces in between. Step 3. Place a male to female wire on the breadboard in line next to the back end of the resistor. This now becomes the negative lead. Step 4. Place a male to female wire on the breadboard where the LED ends. This is now the positive lead. Step 5. Connect the male to female negative lead to port number 6 in the GPIO. Step 6. Connect the male to female positive lead to port number 8 in the GPIO. Let's mount the camera. Step 1. Connect the camera module with the plastic fasteners provided to the camera mount. Use the screwdriver to tighten the plastic screws. Step 2. Snap the camera mount together. Step 3. Connect the camera mount to the Raspberry Pi platform on the top right with the screw and bolt. Use the screwdriver to tighten the screw. Step 4. Attach the camera wires to the camera slot. Let's connect the battery pack. Step 1. Fill the battery pack with 6 AA batteries. Step 2. Put sticky fasteners on the back of the battery pack and then place the battery pack on the robot car. Step 3. Connect the ground wire, which is the black wire, into the breadboard. Step 4. Connect the power, the red wire, into the breadboard. You will notice that the light in the dual H bridge should be on. Let's connect the power bank to the robot car. Step 1. Put sticky fastener on the back of the power bank and then place the power bank on the robot car. Step 2. Connect the end of the micro USB connector to the power bank. Step 3. Connect the USB cable to the micro USB connector to the Raspberry Pi 3. When shutting down the robot car, try to disconnect from the power bank and not from the Raspberry Pi 3. Great job! You have completed building the Raspberry Pi self-driving robot car.